So now that we have our compound interest formula, and we've got an idea of what compound interest is, let's see how we can use this. Let's see how we can use this to answer some practical questions. So I have a scenario here, right? We have $1,000, and we have an interest rate, and we have a time frame. We have this key part here, interest is being compounded monthly. That is the bit that tells me this is a compound interest problem. Right, so I'm pretty comfortable that I'm going to be using the compound interest formula from the previous slide. Right, now when I'm doing these, what I like to do, I like to stay organized, right? So what I'm going to do is I'm going to come over here and I'm going to write down all the variables, and now I'm going to go back to the question. I'm going to kind of start picking out numbers, organize them into my table here, and hopefully in the end there's one variable that doesn't have a value, and that's the one that I'll solve for. All right, so let's see. If you invest $1,000, that's the principal. At 2%, that's the interest rate, and I'm going to go ahead and make that 0.02. I know it needs to be a decimal before I can do arithmetic with it. And I'm going to do this for 3 years. And the interest is compounded monthly. All right, remember, that's the n value. N is the number of times interest is added per year. Compounded monthly means it happens every month. There are 12 months per year. What will be the future value? Excellent. That's A. Right? That's what I needed. All right, so now I'm going to go to my formula here. P is 1,000. 1 plus 0.02 divided by 12 to the 12 times 3 power. And now you go to your calculator, and look, when you do this on your calculator, there are pitfalls here. Okay, first, when you're doing this, it's never written this way in the formula, but I highly recommend that you put parentheses around the exponent. Right? If you don't, depending on your calculator, there's a chance that when you do that times 3, your calculator might think you mean this instead, right? It might not understand that 3 is in the exponent. Throwing an extra set of parentheses here helps to clarify that, right? Now, the next thing, don't try to do this in pieces. Right, I see students they'll do this, and don't well, you can write this if you like, but they'll do 1,000 1 plus 0.02 divided by 12 to the 36th power, and then they'll go to their calculator and they'll do 1 plus 0.02 divided by 12, and it's this really weird decimal. It's 1.0016666, a whole bunch of sixes. It's repeating decimal. And let's say, yeah, well, okay, that's 1.002 to the 36th power, and they think, I mean, that's the tens or thousands place. I should be good rounding to there, right? Well, you might not be. All right, because the next thing you're going to have to do is you're going to have to raise this to the 36th power. And that's an awful lot of multiplying, and multiplying makes numbers bigger. And when you round, not only is it going to make the number bigger, it's going to make your error bigger. Right, and then you're going to come over here and you have to multiply it by 1,000, or if you're doing a really big investment, it could be 100,000. Right, so rounding has the potential to introduce a significant level of error by the time you're done. So, excuse me. So the way you should do this is do this on your calculator. Right, let your calculator hold on to all of these numbers. I'm looking at my calculator right now. I did that 1 plus 0.02 divided by 12, and I have this. My calculator goes out to 25 digits, maybe it looks like. I'm not going to round it. I'm going to go ahead to my calculator and I'm going to say, okay, raise this big, massive decimal to the 36th power. And it's giving me another huge 20 plus decimal answer. And then I'm going to multiply this by 1,000. And I'm going to get, now at the very end, right now they're kind of the last step. I know it's a dollar amount. I'm going to round to the nearest penny. Now I have 1,061.78, right, 78 cents as my final answer, right? That's where we're finished. Okay, so we've got another one here, right? You can pause if you like, right? Pause, see if you can't work this out on your own, then come back and we'll do it together. All right, so again, it's a compound interest problem. I have this key phrase right here, compounded monthly. That tells me this is a compound interest situation, so I'm going to go to my compound interest formula. And again, let's pick out the pieces, A, P, R, T, and N. All right, so let's see. If you invest $863, that's the principal, at 4.2% compounded monthly, that's 0.042, for 18 months. Okay, here's where we have to be careful, right? Remember, the interest rate for that 4.2% is an annual rate. It's in years. So my time value also has to be in years. Right, well, how do I convert 18 months to years? Well, I know there's 12 months in a year, right? So I'm going to do 18 divided by 12, and that gives me 1.5. And finally, interest is compounded monthly, so N is 12. Now here things get a little interesting. I wasn't asked for the future value, right? The final amount. I was asked for the interest. But I can get there from here. I know I'm going to have an extra step. I'm going to find the future value, the amount, and then I'll just subtract out the principal, right? And that'll give me the amount that was paid, that was earned in interest. So let's put some numbers in here. This is 863, 1 plus 0.042 divided by 12 times 12 times 1.5. Remember, it doesn't hurt to throw parentheses up here. Make sure you and your calculator are on the same page. Now, you go to your calculator, and if you enter these numbers, you come up with a future value of $919.07. Well, remember, that's not what we were asked for. We were asked for the interest. Right? And when you think about these accounts, the future value is made up of two things. There's the money you put in, that's the principal, and there's the money the bank put in, that's the interest. Right? So 919.07 equals 863, that's how much I put in, plus the interest. So if we subtract 863 from both sides, we get $56.02. Right? There's our interest. Okay, let's put another one here, right? And let's see. Now, well, let's work it out, right? We're told compounded monthly, so fine. I'm thinking this is a compound interest situation. So let's go to our parts. A, P, R, T, and N. Now here you see things are a little different. If you need $12,000, that's the future value, right? That's A. So I know I want to end up with $12,000. I'm going to invest for 3 years. That's the time, and that's a year amount, right? So I'm good with that. The interest rate is 0.041, and the interest is compounded monthly, so N is going to be 12. Now look to the question. How much do you need to invest? That's P, right? So I'm trying to find P here, and that's okay. I can do that. Right? Look, let's go to our formula. P, 1 plus R over N to the NT power. Now I'm just going to put my numbers in. 12,000 equals P1 plus 0.041 divided by 12 to the 12 times 3 power. Now look, this is an equation. It's an algebra equation. I know, it's got this 1 plus blah, blah, blah over here, and that looks like a hideous mess. But look, that's just a number. Right? That's just a number. If I divide both sides by that weird-looking thing, I'll have P equals something, and that'll be my answer. Now, some textbooks, you'll see it actually does that. It divides by that thing. I like to do this a little more simply. I like to go to my calculator, right? I'm going to say 12,000 equals P, and I'm going to ask my calculator what this is. I'm going to do 1 plus 0.041 divided by 12, and I'm going to raise that. 12 times 3, that's 36. The 36th power. And I know, I warned you, I did this big spiel about rounding, right? But I'm going to write this out here. I'm going to put 1.130647, just so you can see what I'm doing. I still have this number on my calculator, right? So when I actually do this division, I'm going to use that full 20 plus digit number. Now you're going to divide both sides by this, and I get P is equal to, let's see, 12, 1, 2, 3. We get $10,613.39. So that's my final answer, right? That's how much I need to put into the account. So when you're doing this on your calculator, you can use some calculators. They have a memory plus. These are kind of the old school calculators, and a memory recall button. You can use that to kind of stash that number, right? The part that I got from here, so you have that complete accuracy. A lot of calculators today, they have it's usually ANS. It's an answer button, and what that does is it recalls the previous value, right? So you could enter this bit here, then you could say 12,000 divided by, and hit that answer key, and then the equals key, right? And that would get you this answer as well, right? That's using your calculator's memory of what you did previously to keep all of that decimal accuracy. Okay, so that's compound interest. And a lot of what we're going to look at a number of different scenarios going forward here, but all of them really kind of play off of this, right, in one way or another. What we're going to look at in the next lecture is an example of what's called an annuity, which is actually very similar to a compound interest problem. The big difference is, and this is the key factor you're going to look for to distinguish between them. With a compound interest formula, it's one and done. You make one deposit into the account, you walk away, and you forget about it. Right? With an annuity, on the other hand, you're making regular payments. Right? This is a little more like a savings account where every month you put a certain amount into the account, right? So your interest, your principal grows over time, not just because of the interest that's being added, but also because of the dollars that you are adding. Right? So that's where we're going to go in the next lecture.